Okay, so we will start with just wait, what happened? Yeah, no, we were doing Walther Pohl and the picture plates. Gorleben mine in northern Germany is destined, although not yet licensed, to function as a repository for heat-producing radioactive waste in salt rock. The aerial view shows surface installations, the two shaft buildings, waste disposal, and Elbe River in the far distance to the left. Then we have the Sleipner platform in North Sea, offshore Norway, in the world's first largest large-scale geological CO2 sequestration operation. Okay, so CO2 sequestration happens here. On the platform, carbon dioxide is separated from natural gas and pumped into a subsea floor aquifer. Then we have the microphotograph of the coal macerial textinite, a humanite, unjellified woody tissue with intact botanical cell structures in tertiary lignite, Poland. Reflected light oil immersion, long side of image is 0.5 millimeter. Then we have the microphotograph of the coal macerial alminite, a humanite, more or less jellified woody tissue in tertiary lignite, Poland. Reflected light oil immersion, wrong side of image 0.5 millimeter. Then there is microphotograph of the coal macerial sporinite, lignite, wax-coated fossil spores and pollen in Pennsylvanian bituminous coal, USA. Fluorescent light, long side of image 1 millimeter. Courtesy of Maria Masta-Leds in the Indiana Geological Survey. Outcrop of Permian Great Northern Coal Seam below fluvial conglomerate on the Pacific shore, Sydney Basin, New South Wales, Australia. Note the vertical joints. Okay, here you have the vertical joints. See, this is a vertical joint. Okay, vertical joint subdivision, then vertical joint here. Okay, so there are a lot of vertical joints. Vertical joint hai udhar. And subdivisions of seams into piles and plies. And we have the post-mining lignite open pit lake in the Lausitz region, Germany, in the last stages of filling and rehabilitation. Early Mesozoic bituminous rocks in the upper Kali Gandaki Valley of the Annapurna Dhaulagiri zone. Okay, Western Nepal. This is part of the unmetamorphosed sediments of the Tethyan zone above the crystalline Greater Himalayan sequence. Then we have this is a picture of the laying out of a seismic reflection survey line of geophones in the desert of Libya. Okay, so how the geophysicists are laying down the geophones. These are the geophones. This is the geophone. Here another geophone. Okay, for geophysical surveying. And then a fleet of heavy vibrated trucks waiting for the deployment order. Cyrenaica, Libya. Then drilling for CBM, coal bed methane gas, in the Rocky Mountains near Pinedale, Wyoming, USA. Then we have the oil sand mining at Muskeg Mine, Athabasca, Canada. Floating production storage and loading vessel in the Bonga field offshore Nigeria. The field lies 120 km from the river Niger mouth in water more than 1,000 meters deep. Okay, the introduction. Human societies need sufficient water, productive soil, energy in different forms, and organic and mineral raw materials as a base for their physical existence. So, we need water, we need soil, energy in different forms, organic and mineral raw materials for as a base for their physical existence. An additional important requirement is a healthy natural and socio-economic environment. Environment, like economic geology, is a subdiscipline of geosciences. It devotes itself to the scientific study of the Earth's sources of mineral raw materials and to the practical applications of the acquired knowledge. Considering the life cycle of a mine, economic geology leads in the search for new mineral deposits and in their detailed investigation. It contributes to economic and technical evaluations, which confirm the feasibility of a project and end with the physical establishment of a mine. While mining goes on, economic geology provides many services that assist rational exploitation, foremost by continuously renewing mineable reserves and by limiting effects on the mine's environment to a minimum. Possible negative impacts of mining include surface subsidence, lowering of water table, various emissions, and mechanically unstable or environmentally doubtful waste rock dumps. In the phase of mine closure, economic geology helps to avoid insufficient or outright wrong measures of physical and chemical stabilization, recultivation, and renaturalization. In recent years, the economic evolution of industrial and of rapidly developing countries caused incessive changes in supply and consumption of mineral raw materials. China, rather than Europe or North America, provides world markets with essential metals and minerals. So China is important for minerals. Okay. Although at the same time importing large quantities of needed livestock for its expanding population and industry. The future supply of petroleum appears to be unreliable, but its role as the main source of liquid fuels for transport is hardly dented by biofuels and other developments. Wind and geothermal energy are increasingly contributed to electricity production, yet without coal, nuclear power, and natural gas, industrial economies would soon break down and developing nations would be locked in poverty. Ours is a time of transition, but we cannot yet discern the outcome. Whatever it will be, metals, minerals, and energy raw materials will remain a precondition of human welfare. What are ore deposits? Ore and mineral deposits are natural concentrations of useful metals, minerals, or rocks which can be economically exploited. Concentrations that are too small or too low grade for mining are called occurrences or mineralizations. It is very important to understand the economic implications of the difference between these terms. Unfortunately, their wrong application is common and leads to fundamentally misleading deductions. Therefore, the denomination economic ore deposit may be used when a clear attribution to this class is to be emphasized. So what happens, like when we say ore deposits, ore is a rock, not a mineral. Okay, there is mineral deposits is different from mineral. Okay, ore and mineral deposits are natural concentrations of useful metals, minerals, or rocks, okay, which can be economically exploited. If that is a monomineralic rock, then it can be a mineral as well as a rock. Concentrations that are too small or too low grade for mining are called occurrences or mineralizations. So, what are occurrences or mineralizations? When the concentrations are too low. Okay, it is also known as protor. We learned this in one book in S.K. Haldar. It's protor. Okay, it is very important to understand the economic implications. Occurrences or mineralizations. It is very important to understand the economic implications of the difference between these terms. Unfortunately, their wrong application is common and leads to fundamentally misleading deductions. Therefore, the denomination of economic ore deposits may be used with a clear attribution to this class to be emphasized. Note that not all ores are strictly natural. Not all ores are strictly natural. It is very common that the waste of a former miners generation is today's profitable ore, such as tailings of earlier gold, copper, and mining diamond. This is again interesting. Okay, it's just that we are unlucky than our forefathers or ancestors because they have got the main, the prime commodity, and we are left with the tailings, and from the tailings we are getting whatever is there. So, mineral deposits are basically just valuable rocks. Their formation is compared with processes that have or produced ordinary rocks and is investigated with petrological methods. Rob 2005. Mineral deposits can also be thought of as a geochemical enrichment of elements or compounds in the Earth's crust, which is determined by their chemical properties. The ratio between the content of a valued element in an ore deposit and its crustal average is called concentration factor. Okay, so this is it. The ratio between the content of a valued element in an ore deposit and its crustal average Clark value is called concentration factor. Formation of iron ore with today's typical grade of 60% Fe relative to an average crustal iron concentration of approximately 5% requires 12-fold concentration. Copper ore that has 1% copper compared to the crustal average of 0.007% copper in the crust exhibits a 140-fold enrichment. Gold ore with 10 grams per ton distilled from ordinary rocks with 0.002 gram per ton gold attests to a 5,000-fold concentration. Manifold are the processes and factors leading to the concentration of elements and minerals, including the formation of mineral deposits. Rock 2005. Final causes are the dynamic interactions between the Earth's core, mantle, and crust, and of the hydrobio and atmosphere. Cooling and devolatilization of the earth and unmixing of the system in the geological and geochemical cycle and during the transfer of elements have important roles. With reference to the origin, endogenous and exogenous processes systems are distinguished. The first are those resulting from the dynamics of the Earth's interior that are ultimately driven by the Earth's heat flow. At present, the total heat flow at the Earth's surface is 46 plus minus 3 terawatts, 10 to the power 12 10 to the power 12 joule per second, resulting from heat entering the mantle from the core of mantle, cooling, radiogenic heating of mantle and crust by the decay of radioactive elements and of various minor processes. Lay et al. 2008. Exogenous processes take place at the Earth's surface and are mainly due to the flow of energy from the Sun, which is approximately 12.10 to the power 18 joule per second. In rare cases, extraterrestrial processes have contributed to the formation of mineral deposits by impact of meteorites and asteroids. The origin of mineral deposits is often due to a complex combination of several processes, boundary conditions, and modifying factors, collectively making up the metallogenetic or mineralogenetic system. Evidence for such systems that operated in the geological past is always fragmentary. Some questions can possibly be answered by studying presently active ore forming systems, example black smokers in the deep oceans, but this method, actualism, has limitations. Because of the unknown factors, there is often room for different interpretations, hypotheses of the scientific facts. Economic geology strives to improve continuously the genetic models of ore formation, that is, complete schemes of these systems. This effort is assisted by progress and in many other sciences from biology to physics, but the reverse is also true. Economic geology provides a fascinating insight into geological systems that are extremely rare and can only be illuminated by studying mineral deposits. The practical mission of economic geology is the provision of metals and minerals that society requires. Of course, this implies cooperation with other scientific, technical, and financial professionals. Mining in the stress field between society and environment. Okay, so in English, people were always divided in their opinion about mining, as some praised it while highly, while others condemned it fiercely. So this is the age-old war, like conflict area. So Agricola reports that enemies of mining in his time deplored not only harmful effects on the immediate environs, but even moral aspects. They accused mining of advancing greed. Today, this remains one motive of opposition to the industry, but fundamental rejection of any extraction of minerals is more common. Today, this remains one motive Today, this remains one motive of opposition to the industry, but fundamental rejection of any extraction of minerals is more common. The main reasons given are that mining visibly uses the land and often leaves a profound and enduring change. The main reasons given are the mining visibly uses the land and often leaves a profound and enduring change. Certainly, there are often sound arguments against mining at a specific location. Compromises should be sought, however, because mineral deposits cannot be installed at arbitrary places. Their locations are predetermined by nature. Examples are sand, gravel deposits, and river plains. Today, these raw materials are so scarce in many regions that they have to be protected against other claims. Example, housing developments. Yet, everyone consumes minerals and mineral-derived products for homes, heating, transport, computers, medicinal use. Numerous articles of daily life. Mining provides these minerals. Recycling replaces only part of primary production. Recycling replaces only part of primary production. As a percentage of the total area, land use by mining is very small and only locally visible. Biofuel, agriculture, solar and wind energy plants require much more land. Indeed, they create additional demand for minerals. Example, fertilizer, metals for machines and processing plants transport. Toxic elements such as arsenic and cadmium are essential for sustainable energy production, for example, in photovoltaics. Okay, so these are examples of, like, in photovoltaics we need arsenic and cadmium. In many cases, even low footprint technologies such as geothermal power plants have serious problems with waste such as brine, salt, toxic and heavy metals, most notably arsenic, mercury and radionuclides. This demonstrates that there are no simple solutions for a sustainable economy without mining. So here is the thing. Another, we have, like, in many cases even low footprint technologies such as geothermal power plants have serious problems with waste such as brine, salt, toxic heavy metals, most notably arsenic, mercury, nuclides, radionuclides. So mining needs to remove arsenic, mercury, radionuclides so that the geothermal power plants are protected. Okay, this demonstrates that there is no simple solution for a sustainable economy without mining. This demonstrates there are no simple solutions for a sustainable economy without mining. We will keep it till this much and continue in the next part.